developing those physical qualities, the speed, the strength, the power, yet we're not training the underlying psychoperceptual qualities, the observation and the orientation to match that. And when we start running this year's hardware with last year's software, I think that's where we get a mismatch, and athletes are more likely to put themselves in orthopedically sloppy positions that sees them get hurt. Hey guys, this is Keir from Strength Coach Network. If you've been following us for any appreciable amount of time, you'll know that we believe traditional agility training tools like ladders, tippy tappies, any kind of closed environment drills, and we can extend this out to bouncy balls, going in the direction that a coach points, these kind of general reactive things, as to be thoroughly useless for the development of true sporting agility. And what we want to talk about today is a concept that I believe holds the keys to unlocking the development of true sporting agility, and that is the OODA Loop. This is a decision-making cycle or framework that was developed by an Air Force colonel by the name of John Boyd, who was a fighter pilot during the Korean War. And it was noticed during the Korean War that despite relative technical inferiority of the American jets versus the MiGs that they were up against, they were able to shoot down enemy fighters at a much higher rate than the fighters that they were going up against. And it was theorized that the reason for this was the bigger overhead canopy in the American jets. And the reason this was beneficial was it allowed the American fighters to take in a bigger amount of visual information and more quickly orient themselves in space to make an effective decision. And it was from this that the OODA Loop was born. And obviously in war, if you make effective decisions, that increases the likelihood of success and survival. If you make bad ones, you're going to be removed from the gene pool. And given that sport is just war for pussies, we can take those same ideas and apply them to sport. So the letters in the OODA Loop stand for observation, orientation, decision, and action. In the observation phase, we are taking in environmental information via the senses. Obviously in war and sport, this is primarily going to be via the eyes, but we can also rely on the other 4 senses, although hopefully not taste. So in a sporting or agility contest, this is going to entail taking in information about the speed and position of the player with which we're engaging in the contest. It's going to be taking in information about the speed and position of our own location on the field. We may also expand this out to the position and speed of opposing players in support and our own players in support. We might even expand this out to include information from the other senses, for example, auditory information coming in, information being communicated to us by our own players, or picking up on that being shared by opposing players. We might also feel pressure in our bodies from things like wind or precipitation. Once we get to the orientation step, we are trying to create a model of reality. So we are trying to make sense of the information that's coming in. Obviously, not all of that information is going to be useful, so we're going to have to pay attention to important pieces of information and discard the rest. And obviously, the main driver of this is going to be experience. What database of experience in the same or similar situations can we draw upon to inform what we pay attention to and what we discard? We're going to go through 2 different things in this step. One is called analysis, and the other is called synthesis. In analysis, we are drawing upon experience that can be long-term, so our experience in the game. It could even be short-term, so film that we've done to study the habits of a particular player, or drawing upon the experience of previous behaviors within the same game, so tendencies, to infer the intent of the opposition. We know that within the laws of the game, there's any number of potential responses that that opponent can draw upon to try and achieve a favorable outcome. And we're going to ascribe a probability in our head to each one of those. At the same time, we are trying to synthesize our potential response to what we feel the intent of the opponent is going to be. Again, we know through the laws of the game, we have all of these potential options available to us to try and achieve a favorable outcome. And based on previous experience, our likes and dislikes, how we've been coached, maybe environmental factors like the hardness of the ground, precipitation, the weather, we are going to ascribe a likelihood of success to each of those potential responses. And it's when we get to the decision step that we pick what we feel is the most appropriate response, the response most likely to result in success in this given contest. And then in the final step of action, we try and execute this at the highest speed available to try and disrupt the OODA loop of the opponent. The phrase that they used in the Air Force was, whoever closes their loop first wins. This is because the model of reality that we create during orientation is specific to the environmental information that we take in during the observation phase. Obviously, that is just an instant in time. And the longer we wait, the more that information is going to change and the less accurate our model of reality becomes. The less accurate that model is, the less effective any decisions we make based upon it become, and obviously the likelihood of success goes down and the likelihood of failure goes up. Remember also that the enemy gets a vote, the other guy's on scholarship. That opponent is actively trying to work through that OODA loop as quick as possible to change your situation on the ground, to change your model of reality, to make it useless and force you to reset or disrupt your loop. And this reinforces to me why misdirection is so important to sporting agility, because the more effectively we're able to mask our intent, the more likely it is that the opponent is creating a model of reality that just isn't so, and they're going to be forced to commit an error or start their loop again. Likewise, in defense, the better your ability to detect misdirection, the more accurate model of reality you're going to create and make effective decisions from. Now, if you're paying attention to these 4 steps I just outlined, you should notice that only 25% of this cycle is physical. And yet we adopt such a physical first or physically oriented model of agility training and strength and conditioning, which obviously is going to be doomed to failure. We should not be surprised that the data shows us that physical qualities do a really poor job of distinguishing between successful and unsuccessful performers within a given population. We see it in the NFL Combine. It does a terrible job of predicting career productivity once you get into the NFL. Obviously, there is going to be differences in speed of movement and physical qualities between the levels, but it does not tell us the difference about productivity within a given population. So for this reason, approaching the problem of agility as strength and conditioning coaches with only physical solutions may be flawed. Rather, I think we need to take a diagnostic approach so that we can try and pinpoint where within the observation, orientation, decision-making, or action the problem lies. If we run a thought experiment of 2 physically equal athletes, anthropometrically, in terms of their force qualities, they're the same, they have the same 3-cone, the same 20-yard shuttle, physically identical. If we have vastly different productivity within the game of, say, football in terms of yards per reception, yards after contact, defenders beaten, take your metric that we can infer agility from. If there are significant differences between these 2 individuals, logic dictates that because they're physically identical, the difference is not going to be physical, and any kind of physical intervention is not going to be addressing the limiting factor within that system. I can give you a real world example that was told to me by a colleague. This guy worked with a very high level NFL wide receiver, and they brought in a specialist to test everyone's eyes. And it was found that this particular athlete, if his left eye was as bad as his right eye, he would legally be banned from driving. And yet traditionally in football, whenever an athlete has a case of the drops, it's always, go catch 200 balls in the jug machine, practice handling drills, all this kind of stuff. But in truth, this athlete was limited by the amount or the quality of visual information that he was able to take in. And obviously the less accurate this is, or the more strangled this is, the worse the subsequent model of reality is going to be, and everything that follows thereafter is going to be ineffective. And in 1 season of getting this athlete's eyes fixed, he went from around the bottom to the top of the league in yards per reception for a particular year. But if we have athletes that we have no reason to believe their eyesight is off, that they're getting a good amount of accurate environmental information, maybe we're forced to conclude that the weakness might lie in orientation. Has the athlete been provided with enough meaningful learning experiences within that sport as a whole and within the specific context of the contest that we're looking at? If the answer is no, again, we as coaches have to shape the learning environment to provide that exposure to get those reps and to build that database. To steal a phrase from Kevin Mulcahy, who is a great coach that I follow in Ireland, he said, "You cannot master an environment you've not inhabited." Likewise, are we putting athletes into learning environments where they are discovering for themselves what works and what doesn't work based on their own individual timing, likes and dislikes, their skill set, their anthropometrics, or are we spoon feeding them? Given all of the differences that exist between different body types, skill sets, personalities, and so on, it should be obvious that there is no one right answer to solving the problem of agility in different contexts of the sport or the position. So we can't hope to prepare athletes optimally for agility if we're treating them like robots where if X happens, do Y. Likewise, are we feeding them a diet of relevant psychoperceptual information? We have to be sure that athletes are being fed environmental information that matches what they're going to encounter in competition, and they're being provided with the coaching or learning experiences that teaches them what to pay attention to and what not to pay attention to. This is why we can take intelligent, creative, agile, fast, powerful, strong, in short, great athletes from other sports and not just transplant them into similar field-based sports. The most notable example is rugby to the NFL. These guys are elite athletes in rugby, but when they come into football, the information that they're used to detecting and picking out from the environment just no longer applies. That database has to be started afresh, and unfortunately it takes a very, very long time for that to happen, and normally guys get cut before they ever get close to achieving that. It's also the reason that the general reactive drills that I mentioned, mirroring an opponent, reacting to the direction that a coach is pointing, trying to catch a bouncy ball, these do not develop agility in sport, just because the environmental information that is coming in does not bear any resemblance to what is happening on the field of play, and there is no creativity, there is no problem solving like agility in the field. Lastly, this myopic, physical only or physical orientated approach to agility, in my opinion, is probably responsible for at least some of the injuries that we see so often in preseason and training camp in football. This is because we spend months and months and months developing those physical qualities, the speed, the strength, the power, yet we're not training the underlying psychoperceptual qualities, the observation and the orientation to match that. And when we start running this year's hardware with last year's software, I think that's where we get a mismatch, and athletes are more likely to put themselves in orthopedically sloppy positions that sees them get hurt. So in conclusion, I think to really prepare athletes optimally for sporting agility, we need to think carefully about how we progress all aspects of sport and practice. So not just the force, the speed, the metabolic demands of what they're doing, but also the nature, the amount and the speed of psychoperceptual information that we're asking athletes to take in, digest, and formulate responses to. And I've yet to encounter a better framework for doing so than the OODA Loop. So I hope you enjoyed this video. If there's anything else that you'd like to see me talk about on this channel, please drop a comment below. And otherwise, like, subscribe, and share. Congratulations on making it to the end of the video. Why don't you celebrate by watching more just like it? You can also help us on our quest to placate the algorithm gods by liking, sharing, subscribing, and commenting. Thanks.